Assalamu alaikum wa rahmatullahi wa barakatuh. My name is Muhammad Khalid Umar bin Jaha. This is a presentation of my research conducted for my thesis on automatic COVID-19 detection systems using deep learning techniques based on chest X-ray images. To deliver a clear overview, I've divided my presentation into these main sections, starting with introduction, problem statement, thesis objectives, methodology, result and discussion, and end up with my recommendation. So let's start with the first section, introduction. What's coronavirus disease 2019? Coronavirus disease 2019 or COVID-19 is a highly infectious disease caused by SARS-CoV-2 virus. It first appeared in Wuhan, China in December 2019 and has since spread to almost all countries around the world. The World Health Organization declared COVID-19 as a pandemic in March 2020. Most people infected with COVID-19 will experience from moderate to serious respiratory illness and recover without require special treatment. However, some people will become seriously ill and require hospitalization. COVID-19 can also cause long-term health problems, known as long COVID. With the huge development with the technologies, this will lead us to a new term called computer-aided detection or CAD. CAD is a type of artificial intelligence that uses machine or deep learning algorithms to help doctor identify and diagnose disease. As we mentioned, machine and deep learning. Machine learning is a way to teach computer to learn without clearly programming them. On the other hand, deep learning is a subset of machine learning that uses artificial neural network to learn from the data. In this study, we use deep learning because of its advantage. First, ability to learn complex pattern. Second, robustness to noise and outliers. Third, generalization ability. And the last thing, computational complexity. So the problem statement of our research: medical image processing is difficult and crucial in variety of applications. Because the number of COVID-19 cases were rising, the work of discovering COVID-19 cases must be completed quickly. This study will develop a system that can automatically categorize chest X-ray images into normal and COVID-19 cases. The research objective will start with develop computer-aided design system with the capability to effectively differentiate between normal and COVID-19 cases, simplify diagnostic process, ultimately minimize the time and effort needed for accurate assessment of COVID-19 cases, improve the overall accuracy of COVID-19 detection, marking a significant progress forward in the effectiveness of diagnostic methodologies. Let's now move to the next section, which is methodology. In this section, I'm gonna describe the methodology that used in our study. So I've divided the methodology into stages. So as we can see in this figure, which show the visual representation of experiments workflow. So the first stage will start with the input X-ray images. In this stage, we will know about the source of our database, and then we will move to the next stage, which is pre-processing images. In this stage, we'll use different technique in order to pre-process our images and make it ready to enter our system. Next stage is pre-trained CNN models. So on this stage, we'll use different CNN models in order to make prediction of the data and categorize them into COVID and normal cases. After that, we will analyze our data by using a different of performance evaluation, such as accuracy, sensitivity, specificity, precision, recall, F1 score. In the end, we will select our best model based on overall result. So let's now move to the next section, which is results and discussion. The setup and outcome of experiment. MATLAB software was used to train deep learning models for medical image classification. Pre-trained CNN models, Resident 50, AlexNet, GoogleNet, and MobileNet were used. The data set was split into training 80% and testing 20% sets. Five-fold cross-validation was used to evaluate models. Two classes were used for classification: normal and COVID-19 cases, 2,000 normal and 1,000 COVID-19 cases. The data set was pre-processed before being used to train and test each model. So as we can see in this table, which present all performances of 4 different models on each fold for normal and COVID-19 cases. So as we can see here in the first row, which show the performance evaluation, starting with the accuracy, sensitivity, precision, specificity, recall, and F1 score. And here's our 4 models that we used in our study. And here is the number of the fold from 1 to 5. And here is the average of each model. So after applying the model for the dataset, it was so clear that resident 50 achieved the best outcome compared to other models. So as we can see here, for example, for the accuracy, it achieved 99.9% compared it to AlexNet with 98.7 and 98.4 for MobileNet and 99.8 for GoogleNet, and the same thing for the rest of performance evaluation, which is better than the other models. So in order to test the effectiveness of our best model, we applied this technique which called ablation experiments, which is systematic removal or modification of specific layers in deep learning models. The purpose of this technique is to evaluate the impact of overall performance and find ways to improve it. So as we know from our experiments that Resident 50 achieved the best outcome compared to other models. Resident 50 is well known for its depth and excellent performance. So three key modifications were introduced into Resident 50 model: add channel shuffle, add softmax layer, and remove patch normalization layer. So as we can see here in this table, which show the comparison between the results of original Resident 50 model and modified Resident 50 model. So when we added channel shuffle, the system showed impressive outcome with 100% in all performance metrics compared it to original Resident 50. And when we add softmax layer, the outcome was identically same like the original model. On the other hand, when we remove it patch normalization layer, the percentage was decreased slightly in some of performance evaluation. So these techniques will not only help us to understand the components of the model, but also will help in future work in field of deep learning. So let's move now to discussion section. This study developed automatic technique for COVID-19 and healthy diagnosis. Utilize a sizable and balanced test data set for model assessment, included deeper CNN models for performance comparison. So as we can see here in this table, which show the performance comparison of COVID-19 diagnosis technique using chest X-ray images from previous study. So it was very clear that our proposed model achieved a best outcome across all performance evaluation compared to all previous study. So what's the advantages of our proposed model? So here is some of advantages. First, improved overall accuracy. So it was very clear that our proposed model achieved a best outcome with 100% in all performance metrics, which is better than all previous study. Two, large data set. We use a large data set which is larger than all previous study with 3,000 chest X-ray images, included COVID and normal cases. Model lapseness. We use different image processing technique such as noise removal, region of interest extraction, and construct adjustment. So even if with all these advantages, there are some limitations. First, sensitivity to image artifacts and noise. So if the images have problems like spots and other stuff, the model may make mistakes or not work as well. Computational demands. It demands high performance CPU. So if the CPU is low, that will consume a lot of time to get the final conclusion and diagnose. So let's move now to the last section, which is my recommendation. Deep learning techniques best in analyzing labeled images, allowing them to uncover complex connection between image elements and labels. My recommendation will start with CT scan image processing. It's essential to extend models' capabilities to process CT scan images for more comprehensive COVID-19 detection. Real-time monitoring. Integrate real-time monitoring to provide timely warnings for potential COVID-19 cases. This feature will help in emergency situations and speed up patient care. Third, continual model updating. Continual model updating based in the latest medical research and data. Regular updates will enhance the model accuracy over time. Deal with ethical concern. Check and fix any unfair prediction and make it equal for everyone. Collaboration with medical staff. Encourage AI developers and medical staff to work together. This helps improve the model, making it better for diagnosing COVID-19 and meeting the practical needs of the doctors. So for more information in this section which show the references that were used in our research. Furthermore, I'm happy to share that this study has been published in the International Journal of Engineering, Research and Technology in November 2023. In the end, I would like to express my sincere gratitude to King Abdulaziz University and my Professor Yasser Kadah for his support and guidance throughout my academic journey, and thank you for your listening.